Hey guys, so today we're going to explore common factors and multiples. Alright, so we've learned about factors and multiples of a whole number. So in this lesson we're going to learn how to find the greatest common factors the two factors may be, and the least common multiple of two whole numbers. So we're going to start off with our word problem. We're going to have to dissect it a little bit. Notice we have a graphic. It's talking about a closet A that's 12 square feet and a closet B that's 18 square feet. They're talking about area here. So that's a review from 4th grade is area. So let's look and see what happens here. We have a floor plan for a new house, and it shows a linen closet with an area of 12 feet squared and a closed closet with an area of 18 feet squared. The two closets are going to share one wall. What are the possible whole number lengths of the shared wall? So, a few things we need to talk about. Linen closet, in case you don't know. Linen closets. Those are closets in some houses that people just put towels or sheets or things like that in. Tablecloths, things like that. It has an area of 12 feet squared. And then the clothes closet, that's just obvious. That's just where you put your clothes, right? And it has an area of 18 feet squared. They're wanting us to find a shared wall length. Like if you're looking in the classroom, you know, Miss Martin and I, we share a wall. So that wall is the same length on each side. So they're just wanting a wall that would be the same length on each side for 12 and 18. So what I'm going to have to do is I'm going to have to find the greatest common factor here. So we're going to start off with just kind of thinking about what can I multiply to get an area for 12. I could do a wall that was 12 feet long and 1 foot wide, excuse me. That wouldn't be normal for a closet, right? So then you've got, what if I had one that was a little bit bigger? Maybe we could say this one was 2 feet wide, 6 foot long. Or maybe if I did a different one, and I did, these aren't to scale by the way, 3 foot wide, maybe 4 foot long. Those are just some different possibilities you could have. So the factors would be like 12 times 1 equals 12. You've got 12, or excuse me, not 12, Brown. 6 times 2 equals 12, or you got 3 times 4 equals 12. Those are some possibilities. I'm sorry, you didn't see me write down any of that. These are some possibilities of some rooms that we could have. Keep sliding on me. The other one, so let's look at the 18-foot one. So this was the closet A, right? This is closet A. All right, so let's talk about closet B here. Possible ways we could do this. You know, you've got your 1 by 18 you could do, so it could be 18 feet, and this could be 1 foot. Or you could do 9 foot and a 2 foot. Or you could do a 6 foot and a 3 foot. That would be about it, right? There's nothing else that would go in there. So those factors for 18 would be 18 times 1 equals 18. 6 times 2, or 3, excuse me, Miss Brown's just copying what's over there. Let me write that over. 6 times 3 equals 18. Or it could be, oh, I forgot my 9 times 2 equals 18. So we're looking for a common length here. Okay, so I'm going to get a highlighter or a marker, and let's mark some column lengths. Well, they both have a 1, right? They both have a 6, and they both have a 2, and they both have a 3. So our common lengths that they could be, they could have a, so the wall could be 1 foot, 2 foot, 3 foot, oops, I ran out of room, or 6 foot long. It says veggie. It could be any of those. Okay? So you're just finding what their common factors are. We're not even looking for greatest today. We're just looking for common factors. And that's just some possibilities of our wall length. Okay? So let's turn to page 111 in your packet. You know, these notes will be found on Google Classroom, so I'm not going to go over your multiples with you right now. This question is a pretty good question. Any multiple of 12 is also a multiple of 4. Explain this, why this is true. So let's just look at some multiples of 12. You have 12, 24, 36, 48. What comes after that one? 60, 72. Miss Brown's brain stopped. 84, 96, 108, 120. Well, 4 does go into all those. Why would that be? Stop and think about 12. 12 is a multiple of what? It's a multiple of 4. So, yes, because 12 is a multiple of 4. So would this work with 6? Well, yeah, because 12 is a multiple of 6. Would it work with 2? Yeah, because 12 is a multiple of 2. So that works for anything that was a multiple of, or a factor of 12 could also be a multiple of that number. Okay? All right, so let's turn the page. On 112, you are to solve number 3. All right? I'm not going to ask you to do B, so we can just mark that one off. Just look at this top one. You have a rectangular paintings that hang on a wall of an art gallery. One painting is 24 feet squared. The other painting is 32 feet squared. The paintings have whole number side lengths and have one pair of side lengths in common. So one side is the same length. That's what it means in common. They're the same. So what could the common side length be? Well, let's go back and look. We got rectangular paintings. One of them has an area of 24. One of them has an area of 32. Now, finding area is just multiplying the length times the width. So if we look at the 24 and then we look at the 32, I'm listing factors here, okay? So I know 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. And then it starts repeating. So that's our factors, right? I'm not going to start over with the 6 times 4. I'm not going backwards because commutative property says it goes either way. So let's look at 32. You know, you got 1 times 32 is 32. 2 times 16 is 32. 3 doesn't work. Nothing times 3 is 32. So I'm going to 4. 4 times 8 is 32. Nothing times 5 is 32. Nothing times 6 is 32. Nothing times 7 is 32. Picks back up at 8. Well, we've already got it, so I'm not going to do it again. So now I'm just looking for common. I'm looking for what's in common now. So let's look. They both have a 1. They both have a 2. He has a 3, but he doesn't, so I'm not worried about that. But they both have an 8. Okay? Oh, and look. They don't have a 6, but they do both have a 4. So the possible side lengths of our, what are we talking about? A painting that they're hanging on a wall could be. So the possible side lengths could be 1 foot, 2 foot, or 2 feet, excuse me, 1 to 4 foot, or 8 foot. Okay? That's all they're asking you to do today. All right. Have a good day.